If you install a square window on a ship's hull, you haven't just built a window, you have mathematically engineered a crack. That sharp 90-degree corner creates a weak point so severe that in rough seas, it creates a guillotine effect that can tear a steel plate in two. Most people think of a ship as a floating building, but structurally, a ship is actually a giant metal beam. As it rides over waves, the hull undergoes hogging and sagging. The center lifts up, then drops down. The steel skin is constantly stretching and compressing, thousands of times a day. This is where the geometry gets dangerous. If that stretching energy hits a smooth wall, it flows like water. But if you cut a square hole, you create a trap. Engineers call this stress concentration. In a square window, the stress lines pile up in the corners. They have nowhere to turn. At that sharp 90-degree tip, the stress isn't just double, it can be 10 times higher than the rest of the hull. It forces the metal atoms apart. Micro cracks form. Over time, these connect and the metal unzips. Now look at a circle. A circle has no corners. It has infinite edges. When the stress hits the curve, it slides around the opening and reconnects on the other side. The energy is diverted, not trapped. This is why portholes are round, and why they are heavily reinforced with a steel collar to keep that flow smooth. We actually forgot this rule in the 1950s. The de Havilland Comet was the world's first jet airliner, and it looked futuristic with large square windows. But airplanes pressurize and depressurize. They breathe. That breathing caused fatigue at the window corners. 3 planes disintegrated in midair before investigators found the cause. The fix was simple: round the corners. That tiny curve saved commercial aviation. So whether it's a submarine, a spaceship, or a cruise liner, if it needs to survive pressure, you will never see a 90-degree angle.